This is Rick Karg of Residential Energy Dynamics. I'm going to walk you through the RED Calc ASHRAE 62.2 2013 ventilation tool. This longer tutorial is for those users who already watched the short tutorial but want to learn more about using the RED Calc tool and the ASHRAE 62.2 2013 standard. If you're new to using RED Calc free tools, we recommend that you first watch these 3 introductory tutorials. This RED Calc free tool is for sizing whole building ventilation in new and existing dwellings in both single-family and multi-family buildings. An important feature of all RED Calc free tools is pop-up help. Notice when I put my mouse over the label living area, there's a question mark. Each input and result label has a clickable pop-up help for your convenience. I'm going to click on living area now. If you're using a touch device, merely touch the label for the pop-up help. Here you can see the help and the normal and allowed ranges. To exit the help, merely exit out with your mouse or your finger on your touch device. I'm going to start at the top of the tool and work down. New and existing buildings are dealt with differently by the ASHRAE 62.2 standard, so a choice of new and existing is offered here. Our example will be for existing. The next input is Use Infiltration Credit. Select Yes for new and existing dwellings if you wish to account for natural air leakage as measured by a blower door test. Use of a limited infiltration credit for new dwellings is new to the 2013 version of the 62.2 standard. If you're using this tool for single-family dwellings, we recommend that you set this choice to yes. However, if you're sizing whole building ventilation for a multi-family building, the 62.2 standard does not allow the use of the infiltration credit, so in that case, you must set this choice to no. The next section of the tool is where you choose the closest weather station. There are 3 drop-down menus here that you must select from. First, you can select the United States or Canada. I'm going to select the United States. Next, you must select the state or province. I'm selecting Colorado. You can see many of the states listed here. By the way, Washington, D.C. is not included as one of the states. If you're using this tool in the Washington, D.C. area, you will find Washington, D.C. Reagan Airport under the state of Virginia. It's close. This organization conforms to the ASHRAE 62.2 standard. Finally, select the closest weather station. You can see many of them for Colorado here. I have selected the Denver International Airport. Finally, you can see the weather and shielding factor is equal to 0.59 for the Denver International Airport. While you weren't looking, I switched to the Weather Station Data tool. This tool can assist you in finding the closest weather station, even if it's in another state. I have selected Show Map. This portrays all of the weather stations, including the selected one, a red circle, on a Google map that you can move around and zoom in and out on. So the RED dot is my selected weather station. Notice it's selected in the drop-down menu above. These are just like the ASHRAE 62.2 tool. Then the surrounding pink dots show other available weather stations in Colorado and in surrounding states. Well, sometimes it's better to select a weather station in one of the adjacent states. For example, what if you are doing an analysis of a dwelling north of Fort Collins, and it turns out that this dwelling is actually closer to the Cheyenne, Wyoming weather station? In such a case, you would be better to use the Cheyenne, Wyoming weather station rather than the weather station to the south of Fort Collins. One more thing I want you to notice, that for the selected weather station, in this case it's the Denver International Airport, the altitude above sea level is shown, 5,413. Now I'm going to switch back to the ASHRAE 62.2 2013 ventilation tool. Again, I'm going to do this while you're not looking. In the next section of the tool, 4 important values must be added. First of all, the living area. I have already filled in a value here of 2210. If I click in this box, you can see what I filled in, how I filled that in, using a unique RED Calc free tool feature, Math on the Fly. Notice I have included 2 times one section of the house, 24 by 16, plus 2 times the other section of the house, 36 by 20. The house is 2-story, that's where the 2 times comes from. If I click outside of the box, you see the result. If I need to change the entries for Math on the Fly, I can click back in the box and change those entries. I'm often asked if the basement should be included as part of the living area. Certainly, if it's lived in, it should be included. Where I live in the Northeast, there are many basements that have a heating system, water heater, perhaps a washer and dryer. They are within the pressure boundary of the house, but they are not lived in. My advice here is, if the basement seems to be well connected to the living area upstairs, include it in the square footage of the living area. The ASHRAE standard is not explicit about the handling of basements that are not lived in. Next, we have the number of occupants. You can see here that we have a choice of from 1 to 10 occupants. The ASHRAE standard calls for a minimum of 2 occupants unless the authority having jurisdiction approves 1 occupant. I'm going to select 1 occupant so you can see what happens. A warning message comes up in the tool itself that shows you that it's not compliant with the ASHRAE standard. However, you can still go ahead and calculate the whole building ventilation required. Now going back to the drop-down, I'm going to select 4 occupants for my example. For new construction, it's good to use the number of bedrooms plus 1 for finding the number of occupants. You may use more occupants than this, and you may use fewer only if the authority having jurisdiction allows you to use fewer. The next input is building height. For the example, I have entered 17 feet for this two-story dwelling. The standard defines building height, quote, vertical distance between the lowest and highest above grade points within the pressure boundary. This value is needed for the infiltration credit calculation. For some dwellings, the building height is clear and simple, as in the illustration of this simple house. However, more complex buildings might be a mix of 1 and 2 stories. In these cases, although it is more difficult to measure, follow the 62.2 rule of using the vertical distance between the lowest and highest above grade points within the pressure boundary. The final input for this section of the tool is measured leakage at 50 pascals. I have entered 1400 CFM 50. This value is needed for the infiltration credit, which may be used for existing and new buildings in the 2013 version of the standard. For existing buildings, the entire infiltration credit is used in the whole building ventilation calculation. But for new buildings, only a portion of the infiltration credit is used for the calculation. This RED Calc tool takes care of this calculation for you, so you don't have to worry about what to do. The next section of the tool is Use Advanced Blower Door Inputs. Select this section of the tool if you want to adjust your blower door test value for temperature, altitude, or a pressure exponent other than the default value of 0.65. I'm going to select the feature, and again, while you weren't looking, I made some entries here. First of all, the first entry, blower door test type, we have pressurization and depressurization. I'm going to select depressurization. This is needed for the accurate adjustment of entered temperatures. Indoor temperature, I am entering 65 degrees Fahrenheit. Outdoor temperature, remember I'm in Denver, Colorado, 10 degrees Fahrenheit. The altitude, 5,413. This came from the weather station data tool for the Denver International Airport. And finally, the last input is the pressure exponent. If I have done a multi-point blower door test and I know the pressure exponent, I can enter it here. The default value is 0.65. If you enter all of these inputs, you will see that the adjusted leakage at 50 pascals is 1304 CFM 50. Notice the original up here is 1400. If this section of the tool is selected, the adjusted leakage at 50 pascals of 1304 will be used to calculate the whole building ventilation. If this advanced blower door input section is not selected, then the measured leakage at 50 pascals of 1400 CFM 50 is used to calculate the required mechanical ventilation rate. We recommend that you use advanced blower door inputs if, number one, it's very cold outdoors, say a difference between the indoor and outdoor temperature of at least 40 degrees, or, number two, if the house is at a high altitude, or, finally, number three, if you've done a multi-point blower door test and you have found that the pressure exponent is different than the default value of 0.65. The next section of the tool may only be used for existing buildings. If you select New at the top of the tool, this section of the tool is not available. Alternative compliance is a method allowing for existing buildings that do not meet the 62.2 standard prescriptor requirements for local exhaust ventilation fans in kitchens and bathrooms. These prescriptor requirements are, for kitchens, a minimum of 100 CFM exhaust fan that is demand controlled. For bathrooms, a minimum of a 50 CFM exhaust fan that is demand controlled. The alternative compliance method requires that you increase the flow rate of your whole building ventilation in order to compensate for the deficiencies or deficits in your local kitchen and bathroom exhaust ventilation. Using the alternative compliance method is not best practice, but it can save on installation costs. Best practice is to install the minimum requirements that I just stated for kitchens and bathrooms. You can see the values I've entered here in this section of the tool. I have chosen to include the kitchen by checking the box. I have selected to use 2 bathrooms. There's a choice of 0 to 5. I've selected 2. Don't include a kitchen or bathroom here if you know it meets the minimum standard requirement. If you're not sure, go ahead and include it. The tool will determine the correct values. You should know that using the alternative compliance requires you to measure the flow rate of existing fans you decide not to replace with new ones. Notice my entries. The kitchen, I measure the fan. It's 65 CFM with an openable window for a deficit of 15. Bathroom 1 is a measured 25 CFM with an openable window and a deficit of 5. And finally, bathroom 2, I measure it at 30 CFM. There is no window. The resulting deficit is 20. If all of the deficits are added up, the total is 40 CFM. Now, for the results of the whole building ventilation sizing. The effective annual infiltration rate is based on your blower door test. It is an averaged constant flow rate that has the equivalent effect on air quality as the real year-round variable infiltration rate. The total required ventilation rate is the target ventilation rate made up of a combination of natural infiltration and whole building ventilation. It is based on the basic equation 3% of the floor area plus 7.5 CFM times the number of occupants. The alternative compliance supplement. If you selected Use Local Ventilation Alternative Compliance, 1/4 of the total deficit is included as a result. As I mentioned before, this value was added to the whole building ventilation requirement to compensate for the deficit or deficiency in local kitchen and bathroom ventilation requirements. If this is not selected, that value as a result disappears. I'm going to select it again to continue with the example. Next is the infiltration credit. This is the amount of effective annual average infiltration rate that is allowed as a credit. In other words, this value is subtracted from the total required ventilation rate, lowering the final whole building ventilation requirements. For existing dwellings, the infiltration credit is always equal to the effective annual average infiltration rate. However, for new dwellings, the infiltration credit is usually less than the effective annual average infiltration rate. Finally, the required mechanical ventilation rate is the target total required ventilation rate plus the alternative compliance supplement minus the infiltration credit. This is the minimum required continuously operating flow rate of the whole building ventilation. This can be unbalanced ventilation, that is exhaust only or supply only, or balanced ventilation, that is heat recovery or energy recovery. The type of ventilation you install depends upon your climate, budget, and building constraints. This final section of the tool, Whole Building Ventilation Runtime Tool, calculates the required runtime of your ventilation if you don't operate the fan continuously. Our example problem determined we need a whole building ventilation fan of 48 CFM if it runs continuously. We can accomplish this equivalent ventilation rate in two ways. First, we can install a fan with a capacity of greater than 48 CFM and lower its continuous flow rate to 48 CFM with a variable speed controller. Or we can install a fan with a capacity of greater than 48 CFM and operate it intermittently with a controller so that it provides the equivalent of 48 CFM continuous ventilation. This last section of the tool calculates the required runtime per hour to accomplish this. If I enter a value of 90 for the capacity of the fan that I have on the shelf and ready to install, for the equivalent value of 48 CFM continuous ventilation, this 90 CFM fan must run for 32 minutes every hour, or about half of the time every hour. When you use this RED Calc ASHRAE 62.2 2013 ventilation tool, you can be confident you will get the right answer because the tool is specifically based on the ASHRAE standard.